video goes along with Module 8, and we're going to be looking at using Desmos to answer questions about the normal distribution. If you remember the name of the function that you want to use in Desmos, remember you can just type it in here. If you don't remember the name, you can come down here and click on Show Keypad. Click over here to Functions, and then we're going to scroll down to Probability Distributions, and then we're going to select the normal distribution. When I'm answering questions about the standard normal distribution, the mean is 0 and the standard deviation is 1. So I can just type in normal distribution and then click on cumulative probability. And now I can compute areas or bounds. In this week's work, we were looking at how to compute areas. So we're going to keep area selected. And then over here, I can select the region that I'm interested in. Do I want an inner region? And you can notice that it's showing me the region over here, which is kind of nice. So I can make sure that I have what I think I have. The outer region, of course, would be on the outer bounds of what I'm giving it. I can also look at area to the left of a given point or to the right of a given point. So let's look at an example. If I want the area to the left of z equals negative 3.49, I'm just going to select left. And then over here, I'm going to put 3.49. Actually, I wanted negative 3.49 for this one. So that would be the area to the left of negative 3.49 on the standard normal distribution. So you can see that it's obviously a very small area because 3.49 is over here and there's not much in that tail. So just as we would expect, here you can get more digits if you like. Usually we like to keep about 4 digits, so 0.0002 would be the answer for that one. Let's look at the area to the left of 0.92. So again, I'm just typing in 0.92. And here you can see that's going to be a little more area because we're almost to 1 standard deviation. So this is about what we would expect. We have an area of 0.8212 if we keep 4 decimal places. To do an area to the right, I'm just going to click on right. And I might want the area to the right of 2.23. So here's that area. Again, not very much. I would expect a pretty small number, 0.013. I can also do the area between two values on the normal curve. And to do that, I'm just going to pick inner here. And then I'm going to give it the lower bound. So for example, I might want the area between negative 2.55 and 2.55. And so that's going to give me the area in between those two values. And you can see I get 0.9892 if I keep 4 decimal places. We can also do the area in the tails of the curve. For that one, I'm going to pick outer region. And then I might want the area between negative 0.88 and 1.23. That would look like this. So here's negative 0.88, here's 1.23, and you can see that in this tail, plus the area in this tail, I have 0.2988, rounding to 4 decimal places. I can also use the normal distribution to answer questions about a normally distributed variable that does not follow the standard normal distribution. So I might have a problem where instead of having the mean of 0 and the standard deviation of 1, say I have a normally distributed variable with a mean of 50, oops, and a standard deviation of 7. I can enter that right in here. So mean is 50, standard deviation is 7. If I want to use something other than the standard normal, I just enter them right here. And it's nice because it tells you the exact order. The other nice feature, remember, is if I want to see a better picture of my graph, because this graph, I don't have a very good viewing window, so I can just hit this plus, and it'll zoom in, and now I can see a nice picture of that. And let's say I wanted to know what the area was between the values of 40 and 49. Then I just do inner, and it gives me the values from 40 to 49. And I would expect this to be 50 is right in the middle, so less than 50 would be half. So I would expect this to be less than half the area. And then now let's look at an example of a word problem using the normal distribution. So over here you can see that we have a plant that's manufacturing ball bearings with a mean of 5 millimeters and a standard deviation of 0.02 millimeters. So to answer questions about this, I'm going to use the normal distribution because they told me that it's normally distributed. And then I'm going to input the mean and standard deviation. So I'm told that the mean is 5 milliliters and the standard deviation is 0.02. Again, I like to see my graph, so I'm going to click this little zoom fit button here, and I can see my graph now, and I can start answering some questions. Question A says, what proportion of ball bearings have a diameter more than 5.03? So that would mean I would want to find 5.03 over here and find the area to the right. That would be more than 5.03. So I'm going to do a right region, and I'm just going to type in 5.03 here. And that tells me that 0.0668 is the proportion of the ball bearings that have a diameter of more than 5.03. I could also do less than, that would be a left, or I can do an inner or an outer. In part B, I want to know if all the ball bearings that are either less than 4.95 or greater than 5.05 are discarded, what proportion will be discarded? So what I really want to know is how many are going to fall in these tails. So this is going to be an outer question because I want to find out what proportion are less than or equal to 4.95 and greater than 5.05. You can see there's just a little bit in the tails, and that area adds up to 0.0124 if I keep 4 decimal places. I can also answer a question like in part C. If I manufacture 30,000 ball bearings in a day, how many would I expect to discard? Well, if I'm discarding 0.0124, then that's the proportion that I'm discarding. So I can just multiply that. Whoops, 0.0124 times 30,000. And you can see that that would be about 372 of them are going to be thrown away on any given day. I hope that was helpful, and I hope to see you in the next video.